An insurance company's monthly claims are modeled by a continuous positive random variable x whose probability density function is proportional to c times 1 plus x to the negative fourth power, where 0 is less than x is less than infinity. Determine the company's expected monthly claims. So I'm going to show you two methods to solve it. The first way is the generic way, the typical way to find the expected value. But before you find the expected value, you have to actually solve for c. Notice that from 0 to infinity is the entire probability space. So you know that 1 is equal to the integral from 0 to infinity of the probability density function. Okay, so that's c times 1 plus x to the negative 4 dx. Okay, so you know you don't even have to use u substitution. This is straightforward, because if you use u is equal to 1 plus x, du is simply 1 dx, right? So it doesn't change. You can go straight to the power rule. So the power increases by 1, so it's going to be negative third, and also divide by negative third, so you're going to have negative c over 3, 1 plus x, and actually let's write that down as 1 over 1 plus x to the third power, right? Because negative 3 means that this is going to be in the bottom. Evaluate it from 0 to infinity, which is going to be negative c over 3, 1 over, so now infinity plus 1 is still infinity. Infinity to the third is still infinity, right? So that's that, minus 1 over, now the lower limit is 0, right? So 1 plus 0 is 0, 1 to the third is 1, 1 over 1 is 1, right? So that's it. So this is equal to negative c over third. Now 1 over infinity is 0, and then minus 1, so that's c over third. So what does that mean? It means c over third is equal to 1, which means that c is equal to 3. Excellent. So now that we found the c, we can find the expected value. The expected value, as you know, is going to be the x from 0 to infinity, the x multiplying the probability density function, right? So the x times 3 times c is the 3, right? C is the 3 value. 1 plus x to the negative 4 dx. Okay, so that's going to be, we're going to place 3 outside from 0 to infinity, and we can write it as x over 1 plus x to the fourth dx. So notice now you can use u substitution. U is equal to 1 plus x du. Well, actually, let me write it here. Du is going to be 1 dx, and also x is going to be u minus 1, right? You're going to need it for the top. But also we have to change the limits of integration. Notice that u is a function of x here, right? So u is a function of x. When x is equal to 0, u is equal to 1, right? So we start from 1. When x is equal to infinity, u is 1 plus infinity, which is still infinity, right? So x is going to be u minus 1 on the top, and on the bottom is going to be u to the fourth du. Okay, so notice that we're going to have two different integrals, u over u to the fourth minus 1 over u to the fourth, right? Two separate integrals, right? So then let's write it as u over u to the fourth is 1 over u to the third, right? Reduced, which is u minus 3 du. Okay, and then minus 3 from 1 to infinity, this is going to be 1 over u to the fourth, which is the same thing as u to the negative 4 du. Okay, so now the power rule, the power increases by 1, so it's going to be minus 2, also dividing by minus 2, so minus 3 over 2 is the result for the constant. And this is going to be 1 over u squared, right? From 1 to infinity. Now the second one is going to be minus, so the power increases by 1, so it's going to be minus 3, divided by minus 3 is plus, right? So it's just plus. Then we can go straight to the function 1 over u to the third, right? Because u minus 3 is u to the third in the bottom, right? From 1 to infinity. So what are we going to have? Minus 3 over 2 for the first one, 1 over infinity squared is still infinity, minus 1, right? 1 over 1 squared is 1. Then plus 1 over infinity to the third is 1 over infinity still, minus 1 over 1, which is 1. So then we're going to have what? We're going to have negative 3 over 2 multiplied by 1 over infinity is 0, right? And then plus, and then 0 minus 1, right? So 0 minus 1. So as a result, what do we get? We get 3, 2 minus 1, which is equal to 3, 2 minus the LCD is 2, right? So 2 over 2, which is equal to 1/2. So perfect. So you found the expected value using the generic method. Now I'm going to show you another method that may be useful. Notice that it says here in the problem that it is a continuous positive random variable x. So whenever it's a non-negative random variable x, and it starts from 0, in which the 0 point is included or not, it doesn't matter, it's still allowed, from 0 to infinity, and it's a non-negative random variable x, then what's going to happen is that the expected value is going to be the integral from 0 to infinity of 1 minus the CDF, the cumulative distribution function of x dx. So how do we find the cumulative distribution of function of x? Notice that we can write it here. The cumulative distribution function of x can be thought of as the probability of the random variable y is less than or equal to x. Okay, and y is a dummy variable. You could have thought of z, t, any variable you want. And that is going to be equal to the integral from 0 to x of the function of y dy. Okay, and notice that the function that we need is the given function here. Right, so from 0 to x, we're talking about 3 times 1 plus y to the negative 4 dy. So you see, we're just switching the x with the y. Right, because we're trying to find the CDF, because this is a PDF, we need a CDF, right? So this is how you find the CDF of x, of random variable x. So now this is going to be what? We can write it as from 0 to x, we can place 3 outside, 1 over 1 plus y to the 4th dy. Right, so this is going to be fairly simple. So and you didn't have to write it this way, you could have just started from here and using the power rule. So the power increases by 1, is going to be minus 3. Right, so it's going to be just a minus, so minus 3 over 3 is minus 1. So I'm just writing a minus coefficient, because minus 1 is the same thing as a minus coefficient, doesn't matter. And this will be minus 3, the power, right? So it's going to be 1 over 1 plus y to the 3rd power, right? Evaluated from 0 to x, right? So this is going to be what? This is going to be 1 over 1 plus x. Notice I'm just substituting y with x as I would normally, you know, if this were a number, it would be the same thing. Minus 1 over 0, 1 over 0 plus 1, right, which is 1. 1 over 1 is 1, right? So that's good. So that's equal to essentially 1 minus 1 plus x to the 3rd, right? So this is the cumulative distribution function of x, okay, that we just found. So now we use that information to find the expected value, right? So that means we have from 0 to infinity 1 minus 1 plus x to the negative 3 dx, right? Which is essentially, these two ones go away, which is this essentially from 0 to infinity of 1 plus x to the negative 3rd dx. Okay, again, you can use the power rule here. You will see that it's going to be minus 2, so you're going to get minus 1/2, right? Because you can also divide by negative 2, right? So minus 1/2 is the constant, and this is going to be 1 over 1 plus x squared, okay, from 0 to infinity. Right, so now we're going to get what? Negative 1/2. We're going to get 1 over 1 plus infinity is still infinity. Infinity squared is still infinity. And then minus, so 1 over 1 plus 0 is still 1, 1 squared is 1, 1 over 1 is 1. Good. So that's what? Negative 1/2 times 1 over infinity is 0 minus 1, and guess what happens? Negative 1/2 times negative 1 is positive 1/2. So look what happened. You arrive at the same expected value as in the first method by understanding how to use this formula and when it's valid. It's only valid when you're starting from 0 to infinity, going to infinity, and you're talking about non-negative random variable x. Always non-negative. That's the only way this is valid. Alright, so I hope this was helpful. Thanks for watching, and see you in the next video.